All right, so we had a question about Part C um, on the week 3 assignment, problem number 2. This problem involves, in general, all parts of this problem involve the binomial distribution. You should have noticed that since we're performing 5 trials, flipping 5 coins, and each trial has a fixed probability, and we want to know how many of so many tails or heads we get. So that tells you that we're looking at a binomial distribution. Part C is a little more difficult than A and B. Part C is asking about getting at least one tail. Now, binomial CDF is what we need to use here. It's our TI-83 function. I'll show you where it's located. Clear that out. So it's located under second vars, which brings up the distributions. Same location as the normal CDF and PDF, which you may have seen already. So you'll notice that binomial CDF is what we need here. Okay, and then so we want to put in the number of trials we're using. Now, I'm not really ready to use this yet, but we are using the binomial CDF. But remember, binomial CDF measures the amount, it's a probability of being less than or equal to some value. So we need to think about how we can determine getting at least one tail, turning that into a less than or equal to. At least is greater than or equal to. So getting at least one tail is equivalent to saying getting at most 4 heads. Getting at least one tail is the same thing as saying getting at most 4 heads. So we can just think about at most 4 heads. And so n in this case would be 5. And I'm not exactly sure if everyone has the same exact values here, but the question here that I'm dealing with is if you flip a fair coin 5 times, so we're flipping 5 times, so n is 5, the first value you put in is 5, and then you put in p, the probability of heads, because we turn this into heads, 0.5, and we want to do 4 trial, or we want our value to be 4, so less than or equal to 4 for CDF. So this will find the probability of getting less than or equal to 4 heads, which is the same thing as, again, getting at least one tail. And that's 0.96875. Round to 4 decimals appropriately, and you'll get your result. All right, let me know if you have any concerns about what we've discussed here. I'd be more than happy to help.